Hello, Miss Winelander here, and today I'm going to go through the Algebra 1B Unit 2 Lesson 4 quiz retake. So, this quiz is about more multiplication properties of exponents. So today in the recording we're going to go over all the problems on the original quiz, so that will include all the ones you missed and the ones you got right the first time. And at some point in this video, I'm going to say the secret word. So I'll make it pretty clear when I say it. If you're watching the whole recording, and what you have to do is, in that Google form below where you found this video, is you'll type in that secret word, and then I'll send you a webmail with the quiz retake attached. So it just kind of shows that you're watching this recording, that you're picking up what I'm saying during this. Now, even though I'm going to go through all the problems on the original quiz, you only have to do the retake for the problems you missed the first time. But it's a good idea to maybe watch this whole recording anyways, just to kind of refresh your idea and to make sure that you got all those questions that you got right the first time because you understand the material and not maybe you took a lucky guess or just kind of your incorrect worked to the right answer. I know I've done that before. Alright, so let's get started here. So the first question is simplify 5 to the negative first power times 3 to the negative 2 power. So I'm going to grab my pen here. And we know that negative powers mean that they kind of switch up the denominator or the numerator. So in this case, it's like 1 over 5 to the first times, same thing, 3 to the negative 2 means 3 to the 2 is on the denominator. I have to write that 1 up top. Now we know that we can start simplifying our exponents. So 1 over 5 to the first. Well, 5 to the first is 5. Now what about here? 3 squared, so 3 times 3, which is 9. Now when we're multiplying fractions, remember you multiply the numerators, and then you multiply the denominators. So 1 times 1 is 1. 5 times 9 is 45. So your final answer here was 1 over 45. Alright, for problem 2, we're still simplifying, but this time we have only variables. So m times n to the negative 4, all divided by p to the 0 times q to the negative 2. So let's start with one variable at a time. So our m is just going to stay in that same spot. You can't simplify m any further. M to the first power is m to the first power. N to the negative fourth power, though, we know that negatives kind of switch the sign that they're on, switch the side. So it's in the numerator, it's going to go down the denominator. So we have n to the positive 4 power. P to the 0 power. Anything to the 0 power is 1. So you could write 1 down below, or you don't have to, because you know that anything times 1 is itself. Now q to the negative 2 power, since it's a negative power, instead of the denominator, it's going to go on the numerator with a positive power. So your final answer is mq squared all over n to the 4th. Alright, for question 3, it asks us to write in scientific notation. So we're given this number here. What I always think about first when I do scientific notation is I think is a really small number, a really large number. This looks like a smaller number, so right away I know my exponents on my 10 is going to be negative for the smaller numbers. So let's see here. We know that in scientific notation we always have a number between 1 and 10, so it goes a number, then a decimal point, and then anything else. So we want to eventually have our decimal point in between the 4 and the 2. So how do we get it there? Well, it's 1, 2, 3 place values away. So we have 4.2 times 10 at each place value, and how many place values? 3, and we know it's a negative because it's that smaller number. So 4.2 times 10 to the negative 3. Now for number 4, we have to write it in standard notation, so we're given it in scientific, and this time we have to make it standard. Now right away I look at the power of my place value 10. It's positive, so I know that it's going to be a larger number, so this number should be getting larger. So we have 6.12 times 10 to the 3rd. So 3 place values, 1, 2, 3. So we're going to have that 0 there. So our final answer is 6,120. Alright, our next question is simplify and then write in scientific notation. So we have 0.5 or 1/2 times 8 times 10 to the 5th. So if you remember that these are all being multiplied, so you can use those properties if it doesn't matter which order it's in. I know sometimes I forget what they're called, so I have that nice handy little kind of cheat sheet there, but when you change the order that you're doing those in, it's the associative property. So here instead we can kind of think of this like 0.5 times 8 times 10 to the 5th. 0.5 times 8, so half of 8 is 4 times 10 to the 5th. So that's your final answer. Now for number 6, we're still simplifying and then writing in scientific notation, except for this time we have 9 times 10 to the negative 3 squared. So remember when we square something, it's multiplying by itself. So a lot of times I write that out. So 9 times 10 to the negative 3 times 9 times 10 to the negative 3. Again, you can think of the associative properties, so 9 times 9 and 10 to the negative 3 times 10 to the negative 3. So 9 times 9 is 81. 10 to the negative 3 times 10 to the negative 3 is 10 to the negative 6. So we have 81 times 10 to the negative 6. It's not quite in scientific notation, because remember this number here has to be between 1 and 10. So we can get that is 81 times 10 to the negative first. That means we're going to move our place value over 1. Still times 10 to the negative 6. So now when we simplify, we get 8.1 times 10 to the negative 7th. Another way you can approach this is you can distribute that squared symbol there. So we have 9 squared times 10 to the negative 3 squared. Well, 9 squared is 81. 10 to the negative 3 squared is 10 to the negative 6. And then it follows the same process. Either way, doesn't matter how you solve it, there's never one right way to do a math problem. Alright. The next question here is evaluate. So that means we're actually going to get a numerical answer here. So 1/2 a to the negative 4th b squared, for a is equal to negative 2 and b is equal to 4. So let's substitute those in. So we have 1/2 and then a, but this time a we know we're going to substitute in for negative 2. So we have negative 2 to the negative 4th. And then b is 4, substitute that in, 4 squared. Now let's simplify. So we have 1/2 times negative 2 to the negative 4th. Remember, negative 4th means it's going to go in the denominator. So we have negative 2 to the positive 4. And we still have that 4 squared. All right, let's further simplify. So we have 1/2 times 1 over negative 2 to the 4th. So it's negative 2 times negative 2, which is positive 4, times negative 2, which is negative 8, times negative 2, which is positive 16. So it's 1 over 16. 4 times 4 is 16. So now, as we're multiplying across, multiply the numerators and then multiply the denominator. So 1 times 1 times 16 is 16. 2 times 16 is 32. When you further simplify, you get to 1/2. Another way you can think about that is 16 divided by 16 is 1. And then you're just left with 1/2. Alright, for number 8 here, is the following statement always, never, or sometimes true? A number raised to a negative exponent is negative. So let's come up with some examples and see if we can make it true and then make it false. A number raised to a negative exponent is a negative. So what if we had a positive number and we raised it to a negative exponent? Remember, negative exponents make it switch the numerator and the denominator, so this would end up with 2 to the 3rd. So 2 to the 3rd, 2 times 2 is 4, times 2 is 8, 1/8. So here a number raised to a negative exponent is positive. So it's definitely not always true, but now we have to figure out, is it never true or just sometimes? So maybe let's take a negative number this time, negative 2 to the negative 3. So again, that negative 3 power puts in the denominator, so we have negative 2 to the 3rd. Negative 2 times negative 2 is positive 4, times negative 2 is negative 8. So this would actually be negative 1/8. So in this case, a number raised to a negative exponent was negative. So that means sometimes it's negative, sometimes it's positive. So it's sometimes true. Now for number 11, we're going to start simplifying. When we take a power raised to another power. This time we have numerals and we have exponents here. So we can distribute this 3 kind of through. So we have 4 to the third, x to the third, and y squared to the third. This is being multiplied by x to the fifth and y to the fifth. So let's go through and simplify each of these. 4 to the third, so 4 times 4 is 16, times 4 is 64. X to the third, now y squared to the third. That's 3 groups of y squared, so it's y to the 6, or you can think of 2 times 3. Either way, y to the 6, and we still have x to the fifth, y to the fifth. Now let's combine like terms. We have no more numerals, so it's just 64. Now we have x to the third and x to the fifth, so total number of x's would be x to the 8th. Because when you multiply exponents with the same base, you add their exponents, so 3 plus 5. And how many y's? 6 plus 5, 11. So there's our final answer here. Now for number 10, before we actually go through and solve this, I'll just let you know that the secret word today is passion. So I think of a quote sometimes where it says, do it with passion or don't do it at all. So it means, put forth your full effort whenever you do something. Even if you don't feel it, kind of fake it till you make it for a moment there. Just try as hard as you can. So the secret word today is passion. Make sure that when you're filling out the Google form below that you type in the word passion. So again, passion. Now when we're simplifying this, we're going to do that same idea we applied on the last problem. We're going to distribute that exponent through. So we have 2 to the third and t to the negative third to the third. And now we have squared. So we have 0.4 squared and r squared. So let's go through and simplify each part there. So 2 to the third, so 2 times 2 is 4, times another 2 is 8. T to the negative third to the third, so that's 3 groups of t to the negative third, or t to the negative ninth, negative 3 times 3. Now 0.4 squared, so 0.4 times 0.4 is 0.16. Don't worry if you need to take out your calculator for this, it's completely fine. 0.16, and r squared. So let's keep simplifying here. So do we have any like terms? Well, I see 8 and 0.16 or 1600ths. Those are alike, they're both numerals. So if you multiply that out, you actually get 1.28. Now when we're combining like terms here, there's no more like terms. T and r are not alike. So let's see, t to the negative ninth. Well, since it's a negative exponent, we know it's on the denominator. And r squared is a positive exponent. So there is our final answer. So for number 11, that's our last question here, and it was a work pad, that's why it's worth 2 points. It's still the same basic idea. So we have 6x to the negative 2, all of that squared. So it's kind of like saying 6x to the negative 2 times 6x to the negative 2. We usually write it by distributing that squared symbol. So usually we write instead 6 squared x to the negative 2 squared. Same idea over here. So 0.5 to the fourth and x to the fourth. So when we start simplifying, 6 squared, so 6 times 6 is 36. X to the negative 2 to the 2, r squared is x to the negative fourth. 0.5 times 4, so 0.5 times 0.5 times 0.5 times 0.5. 0.0625, I believe. Let me just check. I did this right beforehand just to make sure. Yep. And we still have x to the fourth. So when we start combining like terms, let's combine our numerals. So 36 times 0.0625 is 2.25. And here when we combine our numerals, remember when you are multiplying exponents with the same base, so they both have the base of x, you add their exponents. So negative 4 plus 4 is 0. So anything to the 0 power is 1. So really there's just no more x's here, so our final answer is 2.25. So now that you've watched this video, you've gotten the secret word. Make sure you type that down below in the Google form, and then I'll send you a webmail with your quiz retake attached. If you have any questions, let me or Mrs. School know. Thanks. Bye.